before I jump into this, I'll put a plug in for some other webinars that we are hosting starting tomorrow night. As the Nature Conservancy, we're trying to adjust our programming and provide some additional distractions for folks. So you can go to our Facebook site in Vermont Nature Conservancy and find more information and how to access that as well. So tonight's presentation is about something that I really don't get paid to do at the Nature Conservancy. It just kind of evolved from little bits of knowledge that I picked up about the Poultney River. I've been working for the Nature Conservancy in Vermont for about 15 or 16 years. And when I started out, we had an office down in the southern Lake Champlain Valley in West Haven, down near Fairhaven. Back then, I was focusing much more exclusively on a local basis on areas around the Poultney River. So I learned a lot about the river during that time, particularly about its ecology and the natural history of the area, but also a little bit about the human history. A little bit of the information I picked up during that period of time led to this whole story. It really is a fascinating tale about the history of the Poultney River in the southern Lake Champlain Valley. And the history really has a pretty dramatic and unique aspect to it. And it's something that has had a profound influence on the ecologically rich mix of river, wetland, and upland habitats that exist along the river. Kind of what happened 250 years ago had a really strong influence on what we know of the river as today. So we're up here in Montpelier. I mean, I live here in Montpelier. Maybe some of you are scattered about, but just to help you folks locate yourself a little bit better in Vermont, it's in the southern Lake Champlain Valley. You can see in the inset map here, down here in this part of Vermont, and you can see Lake Champlain over here, and the Poultney watershed is outlined in red. The river itself joins Lake Champlain about this point right here near Whitehall, New York. And the lower part of the river is kind of this area that I'm highlighting here up to this point called Carver's Falls. It's a 150-foot waterfall, and the river splits up into a number of tributaries, the Castleton River, the upper part of the Poultney River, and the Hubbardton River as well. So this story really existed from my ability to assemble a number of different pieces of information that really weren't very accessible until a couple of years ago. It starts from some historical accounts from the 18th and 19th century. Another piece is the evolution of modern river science and how that science has been applied to rivers in Vermont. That started about 2001. And the last part is new mapping and survey and mapping tools from technology. I'll be describing this in a little bit. That's been available only in the past couple of years. And really what's enabled, I mean, this story is, the pieces of the story really, to my knowledge, hadn't been assembled in this way up until these pieces of information were available, and I was able to stitch them together. Basically, in periods of the workday, towards the end of the day, when I started to feel a little brain dead and was desperate, quite frankly, for a little bit of diversion. So I spent a little time doing web research and covered a really interesting story. Now, the lower Poultney River itself, from a purely historical perspective, is a really fascinating human history. It's really well worth looking into a little bit more deeply. From Native Americans to the colonial period, to the periods around the Revolutionary War and the War of 1812, the portion of the Poultney River right where it joins Lake Champlain near Whitehall, New York, is known for being the birthplace of the United States Navy, where Benedict Arnold built some warships for the Revolutionary War. You can go down to the river, and to this day, and when the water is low, you can still see the remains of a British warship from the War of 1812, which was mothballed in the Poultney River at the end of the war, called the HMS Linnet. A lot of interesting backstories it's well worth reading more about it. From a natural history perspective, the Poultney River has long been considered a biological treasure in Vermont, not only for the river, but for the forests and wetlands that surround it. Now, the river itself is designated as a Vermont Outstanding Water Resource in 1991. It has 43 different species of fish and 12 species of native freshwater mussels. Now, 6 of those mussels are one of my favorite my absolute favorite taxonomic group. 6 of them are listed by the state of Vermont as threatened or endangered. It's the most diverse river in terms of mussel populations in the state. And it's got 2 Vermont state-listed threatened endangered fish, a channel darter and the eastern sand darter as well. Really a biologically rich area, and that's one of the reasons why we at the Nature Conservancy have long been interested in it from a nature conservation perspective. Going back 25, 30 years, we've invested quite a lot of resources in protecting and managing preserve lands in that area, and also doing other river-related conservation work. Some of our early river protection efforts back in the 1990s occurred in the lower Poultney River Valley. As a result of all those efforts, we have a preserve network down there that covers 12 miles of the lower river. Actually, the 12 miles of the lower river is the length of river channel that exists between Lake Champlain and this point up here, Carver's Falls. And of that 12 miles, on the Vermont bank, we've got 4.6 miles of protected riverbank and 9.2 on the New York side, which is about 58% of riverbank length that's under protection. Of course, all the forests and uplands, which are also under protection, total about over 6,000 acres, both in Vermont and New York. Let's jump to one slide ahead, go back, because in my book, mussels always come before fish. I know it's not true if they're going to everyone else. But as I mentioned before, there's a biologically rich fauna of mussel fauna in the lower Poultney River. It is largely there because of the fact that Lake Champlain used to have, back in times of glaciation, had connections to the Great Lakes, and through which a lot of fish and mussel species were able to migrate. So we have mussel species in the lower Poultney and other Lake Champlain tributaries that don't exist anywhere else in Vermont. And in fact, the Poultney River and some other Lake Champlain tributaries have the richest freshwater mussel fauna of all New England. The Poultney has a whole bunch of rare and interesting fish. The one up here in the top, the eastern sand darter, is considered globally rare. They're really abundant in the Poultney. They live, they burrow down in these sand deposits in the bottom of the river, and if you know where to look for them, they're actually easy to find. There's another rare darter called the channel darter. And another interesting fish, I just put it up here because it's an example of one of the species that you find pretty common in the Midwest, and it's common in Lake Champlain. But if you were kayaking around Lake Champlain, you might see them basking in the summer near the surface of the water. It's a spotted gar with this distinctive long nose here. Really big, neat, interesting fish to see that are easily noticeable. And not to, I also want to mention the rich riparian floodplain and wetland complex that exists at the junction between the Poultney River and Lake Champlain. Really a rich mix of habitats that makes it a really special place. Now I'm going to switch gears a little bit and start talking about rivers in particular. And when you're thinking about the Poultney River, a little bit of useful background to keep in mind are the changes that have happened in rivers throughout the state of Vermont over time. Now, we all know the topography of Vermont is we've got hills, we've got mountains, not a lot of flat land. And throughout much of the state, we've got a general pattern. We're through river valleys, we've got roadways. It's one of the flatter parts of the state. deep soils which are better suited for agriculture, and rivers, of course, run down the river valleys. So during settlement times, a lot of the rivers to make agriculture and road building and settlement easier were kind of moved and pushed off to the side of river valleys. So the rivers used to meander through these valleys, and now you'll kind of see, it's pretty common, they kind of hug the edges, and they were kind of pushed over here and redirected. And you can see that in a lot of different places. This is in Fairfield, this particular creek, and you can see how it was moved to accommodate this railroad. In the roadways, you can see these meanders which were cut off. And this is in Huntington, again, pushed off against the side of the valley. And in Waitsfield, the Mad River, again, off the side of the valley. And if you go down to the river and actually look at these, if you're really not familiar with how rivers have changed in Vermont, you really might not look at this and notice that anything is kind of in somewhat of an altered state. But if you see straight sections like this in a river valley that's relatively flat, it's probably been straightened, and the river channel has probably been straightened and moved. Now this is actually the Upper Poultney River. Same story here. Carver's Falls is here. This is a little bit upstream of where I showed you earlier. This is the town of Poultney. Fairhaven is up to the north here. You can see how the river valley has been pushed off to the side of the valley. And this can have ecological consequences because the river functions differently when it's altered from the form that it naturally wants to be in. It can affect types of the quality of the habitat that exists in the rivers or streams. It can alter floodplains because rivers can, under some of these circumstances, call kind of incising or downcutting into the bed, and the river, after something like this happens, the river floods and can no longer spread its floodwaters out into its floodplain. That can cause erosion and have water quality implications. And I want to show you two pictures which really illustrate some pretty awesome power that rivers have to move materials around. This is Wardsboro Brook in southern Vermont. This picture is taken with a game camera for another project. But you can notice the brook here, and I've indicated a couple of reference points here. There's these two arrows point to particular rocks, and this was about a couple of weeks before a big rain event and flood came through. So afterwards, what I'm trying to show you folks here is how the rivers changed just in a moderate level flood event. The water actually came up to this upper line right here. So if I go back and forth, jumping ahead. You'll notice how the river has changed. What I'm seeing here is that a lot of these boulders and coarser, larger size materials were washed into this channel and raised its elevation a little bit in comparison to these reference points that are marked with the arrows. Oops, going the wrong way again. I'll show you once or twice more. It's really pretty dramatic and an interesting example of the power that moving water can have in shaping our river systems. Now in the lower Poultney River, we've got alterations to the river channel going on because of how the water is flowing. And the flow patterns that exist there are in part a result of channel alterations, some of which are these channel straightening practices which have occurred upstream, but there are also some other things going on which really relate more to the history of the river itself, and I'm about to launch into that in more detail. But I want to point out right here that we have these areas there, and they're fairly frequent, of instability where the bank slumps off into the river. The river comes up against these erodible soils, these high banks, and this happens this occurs quite frequently in the lower part of the river. And if you paddle down the lower part of the Poultney River, one of the things which you may notice is that, and there's actually two kayakers here. There's one here, there's one downstream, and this kayaker gives you a better idea of the scale. There are these high terraces, and this is about a 15 feet elevation difference between where this kayaker is and the top of the bank here. And that's a huge difference for a river like that. Usually with rivers, when they access floodplains, it's not nearly that great. So this river, this is like the first clue that if you knew what to look for in this lower Poultney River and you saw this bank, you'd start thinking about why is this bank so high? Why is there so much sediment down here? Why does this river seem to be so different from what you might expect it to be? It's a pretty subtle difference if you're not used to looking at rivers. But if you are used to looking at rivers and studying them, it's something that which would definitely catch your attention. And those banks aren't so high that the Poultney can't flood. This is right after Tropical Storm Irene a number of years ago. This field in West Haven, Vermont floods very infrequently because those terraces are so high with respect to the river, but it's still can access, the water can still access its floodplain on occasion. Now, I'm going to move on a little bit to the history of the river. And one of the things that this whole story of the history of the lower Poultney River starts with an understanding in the colonial times of the importance of navigable ports in Lake Champlain for economic development. Lake Champlain was a lot of the trade and movement of goods occurred by way of water back in colonial times. So ports were important economic centers. And when I use the word port, it really, if you think about that in a modern sense, you think of some big body of water, big deep body of water with huge, massive ships and cranes and everything. And back in the mid-1700s, this is a painting of Whitehall, New York, and this is really this is what is called the head of, I think, East Bay in Whitehall, and it's really small little boats. And this was a big important commercial port in Lake Champlain back in the 1700s, and just the size of to our thinking about what ports look like today, it doesn't look very impressive, but it was quite the center of commerce way back when. So just if you looked at this on a map, and this is an old map from 1905, one of the earliest maps of the region. Here's Lake Champlain. This is the Poultney River coming down here. What we're calling a bay, and here's Whitehall, really on a map doesn't look much different from a river. The vantage point for that painting was right here, looking into the village of Whitehall itself. And if you're familiar with that area at all today, you'll kind of scratch your head because there's a lot more open water there now. There's since been a really big channel dredged through the wetland to allow better shipping access to the lake. Our story with changes to the History River really starts with some historical documentation, and this is the source of some of the historical tidbits that I learned about the Poultney River when I was working down in the southern Lake Champlain Valley. One of the pieces of information was that the river right adjacent to one of our preserves on the river, in the town hall of West Haven, Vermont, had some old land use plans that laid out that were planning for the use of this property to be the center of a town that never got built. Streets were laid out and plans were drawn up to create this town and what's now a preserve right along the Poultney of the river, on the Poultney River. Looking more closely at this document, The History of the Town of Fairhaven, Vermont, it describes how ships of up to 40 tons capacity could sail up what they call East Bay to the site of this proposed town, which is the Nature Conservancy preserve we call the Sod Farm today. It described this bay as having a depth of 10 to 12 feet. And it refers to this as East Bay. And it also describes East Bay as being just below Carver's Falls. Now, if you remember back to an earlier slide, I talked about how the lower part of this river was 12 miles long. this document doesn't say what it means by this word just. Like how long is that? What kind of distance measure is implied by the word just? They don't say, and I don't know, but I guess it would be shorter than 12 miles. So really, this is the first clue that East Bay was once much more extensive and extended much farther up what we now know as the river. So East Bay, this document also describes that East Bay included anything up to something called the Hessian Road Crossing. So that got me to thinking, well, what the heck is the Hessian Road Crossing? What is that? Oops, going the wrong way again. Here we go. So to look at this on the map from what I once described, here is our sod farm preserve. Here's Whitehall, here's Lake Champlain, here's Carter's Falls. So this is, again, this whole distance here is about 12 miles. And so this document is basically describing that ships of 40 tons capacity could sail up to about this point in the river. So thinking a little bit more about this puzzle about the Hessian Road Crossing, there's some conflicting historical information about where exactly this was. There's a reference to it in the 1992 Poultney River Management Plan that was authored by the Vermont Agency of Natural Resources, describes the Poultney River about being well upstream of Carter's Falls. But again, this 1870 document tells us that ships were able to sail up to Hessian Road. So we're looking again at this old map. This map dates back to 1905. This map shows two bridges on the Poultney River. This one in particular is still there, but this one's not.
Hey, Paul, just let you know that we can see your highlighter just fine, but we can't see your mouse cursor.
Okay. Okay. Thanks, Sean. So I'll start highlighting things that I'm pointing out. Okay. So this bridge is not there any longer. This bridge is. So that it gave me the first clue that this particular location may be what they're referring to as the Hessian Road. Again, with ships being able to sail up to this point in the river. This is the earliest map that I could find on the web of the Lower Poultney River. Again, it's got this particular bridge here, which is the current existing one, and this one, which doesn't show as a bridge, but again, not inconsistent with, doesn't really negate my hypothesis that this is the Hessian Bridge or Hessian Road. Now, there's really another really interesting puzzle piece for this whole story is relates to some information around something called Captain Johnson's sloop from the Royal Navy. I got this information from a website that you folks can look at if you're interested down here. And this guy, his name's Lawrence Gooley, and he wrote this, he created this web page to tell the story of the ship that was uncovered in the bed of the Poultney River, and it actually had a chest full of gold. So it's really a buried treasure story in the Poultney River in Vermont. Who would have thought? But the real story is actually really interesting. This sloop was part of the British Navy, and in 1777, during the Revolutionary War, the ship sailed south in Lake Champlain from Quebec. It had a bunch of gold and silver to pay British troops. And in the process of trying to find the British troops who had gone over to Hubbardton for the Battle of Hubbardton, it sailed up the Poultney River. It was attacked by some colonial forces. The British abandoned it and scuttled it. So the ship was buried and was undiscovered until it was uncovered by some erosion from a flood in 1901. And the wreck was the description of the discovery of the wreck, the location was just below Carter's Falls, not far from the bridge to Albany. Here I'm thinking that this is the very same bridge that was in existence in 1901. describes it as being 8 miles upstream from the Elbow, which is where Lake Champlain joins the Poultney River. So again, thinking here that the bridge to Albany is the Hessian crossing. And if you look at a map, I did measure this distance, and it is about 8 miles. So it all seems to be consistent. So the next question is, so we know that a sloop sailed up there, and we have some information. So we know from before that ships of about 40 tons of capacity could make it up there. We know that Captain Johnson's sloop from that website had a description of about a crew of 10 or so. And so I went to Wikipedia. I was trying to think, well, how big is a ship that has 40 tons capacity? And I came across an entry for a description of this type of craft. And I don't know if these types of craft were actually on Lake Champlain during this period, but these were cargo vessels that were fairly commonly used during that period, called Bermuda sloops. As far as I could tell, the length of a ship that corresponded to this level capacity is about 22 to 28 feet long. So that's a fairly large boat that was able to sail up to up the river, or what was then known as East Bay. So that was in the late 1700s. This picture was taken in the Poultney River about a mile or two downstream of the sod farm, probably about 3 miles from where that ship was found. Instead of the 8 to 12 feet of water that was described there in the late 1700s, when the river's low, you're in some places you're hard pressed to find 8 to 10 inches of water. So it really kind of, it really is an indication of some of the changes that have happened in the river over time, and it's pretty dramatic. It's hard to really, to the extent that it's really hard to imagine what it must have been like back in the late 1700s. But it's not altogether inconceivable that it could have been that way. North of the Poultney River on Lake Champlain, this is in Addison County in Orwell, there's a place called East Creek, which is a big complex of wetlands. You can see Lake Champlain here in the distance, and the creek kind of meanders around here. And it meanders like this for about 4 or 5 miles. It's really a rich wetland complex, and the river channel is fairly deep. It's often deeper than a paddle. So it's not hard to imagine larger boats being able to sail up a system not too different from this. So I'm thinking that the Poultney River was maybe more similar to East Creek than what we see today. Another example is the Lachute River. This is Ticonderoga on the New York side, fairly deep channel up until where the gradient of the river starts getting greater over in this part. So looking at an overall, again, here's the river valley. Carver's Falls is here. Whitehall's down here. The junction with Carver's Falls is up here. The junction of Lake Champlain is down this way. And I've included contour lines here because really in the contour lines you can see areas where there's not that much elevation gradient. And you can see there's this big marsh in here that I'll highlight. So this is all about the same elevation, and you can follow that more or less up the river valley, and you get a shape that looks a little bit like that. So this is my hypothesis. This is really kind of rough. This is my hypothesis for where what was once described as East Bay used to be, and now it's just a river. It's got these really shallow conditions almost all the way down. So again, trying to visualize this as a bay more than a river with all the sediment and these high riverbanks. The next part of the story, moving on from the historical accounts, goes on to river science. Now, back in the early 2000s, the state of Vermont started to use a way of assessing river conditions based on their geomorphology. That's basically simply saying they're looking at rivers from a perspective that asks questions about, is the river flowing, is the river channel in a pattern that we would expect it to be in terms of its size and depth, considering the conditions upstream. That relates to watershed size, the amount of water moving into the channel, the type of landscape it exists in, and the type of material that the river moves through. It's a fairly complex field of study, and it's really fascinating. I don't have time to really go into it, but one of the first geomorphic studies that the state did as a pilot project was on the lower Poultney River. And one of the findings from 2001 was that this portion of the river down here, again, this is the sod farm, had noted this 14 foot of sediment that I pointed out in those photographs, and hypothesized that it was deposited from land clearance by early settlers, basically thinking that during the 1800s, we know that Vermont was largely cleared for sheep farming, and that quite a bit of the sediment that existed in the lower part of the valley washed into the lower part of the river and filled up East Bay just from the fact that the land was denuded, and that all the soil and stuff washed into the river and was carried downstream after the vegetation was removed and the sheep are grazing it. That was the hypothesis that this particular study came up with. Some interesting clues that are consistent with that hypothesis are these old floodplain forest stumps. And this is the Poultney River right at the sod farm site where ships were documented to sail up to in the 1800s. And there's four or five of them here. And these stumps grew at an elevation of the former floodplain back in the 1700s. But right now they are right in the river, and you can only see them when the river is low. Usually, most conditions you can't see them. The river's up over the top of them. So just from this alone, we get a sense that the floodplain and the river itself was once at a much different elevation. And really, when I say river, it was when these stumps were trees. That was back in the day when this was not considered a river and was considered instead a bay. So we've got our hypothesis from this study, but there's historical documentation that tells a slightly different story. And this is from the Gazetteer of the State of Vermont in 1824. And it goes on to describe, I'll just go through a little bit of it to start off. It tells about a remarkable change that took place in 1783, a little above its junction with East Bay. Again, junction with East Bay, this is the East Bay of 1783, which occurred much farther upriver than we now consider it. The description goes on down here saying, during a violent freshet, which is basically a flood, the river broke through a ridge, and meeting with no rocks cut out a channel 100 feet deep, lowering the bed of the river for some distance above and carrying immense quantities of earth into East Bay. It goes on to say that the bay, which again, here we go, the bay was navigable to 40 tons, to ships of 40 tons burden, and it was filled up so that it was no longer navigable and a canoe could hardly pass by. So here we have a slightly different story for what happened in the lower river than the hypothesis from this study. The history of Fairhaven has a similar documentation. Basically, the same text describing that a flood in 1783 carried vast quantities of sand and filled up East Bay. And you've got this awkward wording that was used back in the 1870s. It's basically, until then, had been accessible to vessels of 40 tons burden, and promised, had it continued of its original depth, to render the town along its banks a place of considerable commercial importance. You got to read that a couple times to get that. I mean, I had to read that a couple times to get that. It was basically saying that the town that was once planned as a port on the sod farm was abandoned because the river was filled up with sediment and was no longer able to be used as a commercial port. So the text in this particular document also goes on to tell an interesting story about the potential origin. We had in that previous document, it talked about how a flood eroded a ridge of land. This document described how this ridge of land was possibly eroded in the flood, or a property owner cut a little ditch across it to help it on its way, to help cause this change. Now, not sure exactly which of those actually happened, but we do know that these text descriptions describe an instance where a waterfall was abandoned by this river adjustment. So there was a waterfall, and the river bypassed the waterfall. Waterfalls were once a really important commercial resource for mill construction, so they were coveted properties. But there was a land dispute around this waterfall, and the slighted party, the party that was slighted, decided to try to relocate the river so that the person who gained this property would no longer have a waterfall to take advantage of from a commercial basis. These text descriptions are largely consistent with these two other sources right here. The first one was from 1915, the other from 1929. So we've got really two important pieces of the puzzle that describe when, what, and where. But the where piece is really interesting as well. And that's kind of the final part of this presentation that I'm going to describe. And so here we have the sod farm again. So I tried to figure, using that text description that I read out earlier, I'm about to read it to you. I didn't read that portion of it to you yet. Tried to figure out where all this happened. We know that Carver's Falls is right here, so it probably happened upstream of Carver's Falls and somewhere in this section of the river. And this is where we go to some modern mapping technology. There's something called LiDAR, which is basically a detailed landscape way of creating detailed landscape maps. It's from airplanes using pulsed lasers, and these lasers are reflected back up to the airplane. It was developed for Vermont in the past 10 years, and it looks something like this. It's an aerial photograph of Poultney, the Green Mountain College campus, and you can see the Poultney River here, and what you'll notice in the LiDAR are these old river channels that you can clearly see. So it's really, really a great way at looking at these finer scale landscape features. This is another example. This is in West Haven and Route 22A. You can see these old meanders of rivers. And this is the Hubbardton River, a tributary of the Poultney. You can see the river has just adjusted its course over the years. So here's Carver's Falls. So the sod, this is well upstream of this. This is upstream of the sod farm. This is where the river goes downstream into the lower part of the valley. So this is the area where this is somewhere up here where the adjustment happened. If you can look at the same area on LiDAR, when I looked at the orthophoto, the first thing I noticed are these really weird marks and these fields. So these actually look to me a lot like old meander bends. So really looked like there was an old floodplain here, much like you see in other river systems in Vermont. You can kind of see that here on the LiDAR map. So I went on to look at a topographic map of that same area. And indeed, you can see how flat this area is. It looks like what you'd expect a floodplain to look like, with the river kind of running right down through here. But unlike what you'd expect of a floodplain, if you look at the elevation gradient lines, this is about 300 feet in elevation. If you count the elevation lines down to the river, so between the lower part here and the upper part, there's a difference between 300 feet between 180 to 240 feet of elevation. So that translates into a difference between approximately 120 feet to 60 feet. So here, this particular circle right here, this is about 100 feet above the river. So obviously that is a huge difference that is a huge elevation difference. You'd never expect an active floodplain to be that high above a river system. So zooming in here a little bit more, here you can see some of these old river meander bends, and you can actually see up here an old river channel of some sort, and you can see kind of the bends in here. So I was kind of puzzling over these features, trying to look at these and figure out where did this happen? You've got this really weird bend in here that I thought was somehow part of the story. But go back to the text of this, back in this historical document, and reading this, it's really not very helpful. It's really puzzling. You know, a little bit above its junction with East Bay, a ridge of land crosses in a north direction. The river runs a northwest course. On meeting the ridge, turned suddenly towards the northeast, and after keeping to the course about half a mile, turned west, running down a steep ledge of rocks and forming a number of fine mill privileges. It's really hard to cross-reference that information with a map. And my investigation stalled there for probably 8 months or so. So, you know, this kind of end-of-the-day investigation where I would do these web searches when I was kind of brain dead, kind of stalled there, and I kind of gave up on it. And I don't know what motivated me to take another stab at it, but one day I did a web search, and actually, so it's kind of a little bit of a spoiler there. But again, here's the sod farm. Here's the area of the river that I was looking at, trying to figure out what was going on and where did this adjustment occur. And during one of these web searches, for some reason, I can't remember the term I searched on. I hit images instead of all or whatever it was, text or something like that, and I saw this. And after having looked at the map of that portion of the Poultney River for so many times, this really struck a bell. And I just I sat up straight in my seat immediately upon seeing this. This was an illustration. I easily recognized this as looking a lot like this section. Here's the Poultney River. Here's the Poultney River. Carver's Falls is up here somewhere. From this old riverbed feature that comes out in the LiDAR. Like, wow. Really looks like I was onto something there. That illustration came out of a textbook that was written in 1860. This guy, C.B. Adams, was the first state geologist from the state of Vermont. And he drew up that map describing what happened and exactly where it happened, where this river adjustment happened. So this illustration has a legend. A bunch of letters correspond to descriptions of what actually happened. So it turns out that this section here indeed was an old river channel that became abandoned. This area right up here was the waterfall, which was abandoned. So the river used to go this way and run down this waterfall. So the river channel, this is the present river channel. It now runs through this area, and that the ridge that was eroded away was right here. So the river used to flow in this direction, and doubled back and came this way, and this was the ridge that was eroded away, and it broke through here. And when the river broke through, it created this dramatic adjustment where these old falls were abandoned. So this is what it looks like on the LiDAR map, kind of marked up to show where I think these features are. And this is really a map which it really uses LiDAR to create really fine elevation gradients. Carver's Falls is up about here. This whole area is right in here. You can see this area is really the old river channel, and the old waterfalls right here. So you can see up here, the river channels are, especially up here in the Castleton, are clearly defined by these black markings. So, and again here, but only this time, this is not a river channel. This is totally dry, but completely looks like a river channel here. So, but now we solved this issue, that we solved the mystery of where this happened. And really looking at the entire valley, this whole elevation gradient, all the sediment that washed down and filled up East Bay came from this gorge up here. Again, 120 to 60 feet deep. Upstream of this old ridge right here, the old waterfall, and the river cut this valley. And you can look at, I went to Google Earth, you can get this neat landscape kind of perspective. Here's the dry falls, right? The old waterfall right here. And here's the old river channel. This was taken in the spring, so you can see water in the old river channel. And you can kind of get a good perspective on the size of the gorge, which was excavated when this adjustment happened back in 1783. So, and it goes up the river quite a ways. And this is looking same area, same spot. Here's the falls. Here's that old river channel, but looking downstream to upstream. Carter's Falls is right about here. So, and one of the interesting, what do the old falls look like? Well, about a year ago, I was able to take a side trip for some other field work we were doing down there. We contacted, it's on private land, so it's not accessible to the public. We got permission from the landowner. And it's really interesting just to go to this site. If you visited this, you take a look at it and you wouldn't guess, not knowing what happened there, that it was an old fall, is an old waterfall. But looking at this site with the knowledge and perspective of knowing what happened back in the late 1700s, it's pretty clear. It's clearly an old lip of the waterfall right here where the water used to tumble over. And there's even a big scour pothole here where falling water interacted with some softer rocks and other boulders and kind of carved out this pothole in the ledge. So really, if you walk down into the river valley, which I had a chance to do last year, it really has this unusual, very raw feeling to it, kind of bank instability. If I didn't know what happened there, I'd kind of look at that and kind of really note, in a way, note this kind of rawness of its appearance, but really not be clear on why it looked that way. But having all this other information gives me a new perspective on the river and why it looks the way it does today. So this is basically the old falls, and this is to give us you folks a sense of the area from which was eroded away and all the sediment that got moved into the lower valley and filled up East Bay. And if you look at this from a larger perspective, here again is where this is where all that sediment was eroded into, and really the source of all these sediments up here, this deep sediments that occur in the floodplain, the lower Poultney River, and putting the picture together and creating a more complete story of what happened to this river back in the late 1700s. But really, that's the end of the story. I mean, LiDAR is a pretty neat tool. You can see lower in the Poultney River, there's evidence of other changes that have happened over time. You can see what are now wetland complexes, used to be rivers and old river slumps and stuff like that. It's really a neat tool, but the clues that it provides really doesn't, the other stories that exist there aren't nearly so dramatic or interesting as that particular story. And this is more or less what the lower Poultney River looks like today. So it's really this whole tale really leads you to look at this picture and try to envision what this might have looked like with more of a, when the river was more of a bay, when this channel was navigable, and this is really a more connected series of still water and wetlands in here that ships were able to sail up into. And that's all I have. I think I actually finished before 6 o'clock, which is what I was hoping to do. And I think we've got a couple of minutes for questions, if any of you have any.
Folks are welcome over in the chat bar up at the top right. And while we're waiting for some to pop up here, I actually had a quick question, Paul. I'm wondering if you happen to look at the soil in that former channel at that kind of perched, what would have been a wetland that's now, I guess, a farm field. I'm wondering if there is any kind of indication in the soils or the botany around there that it was like super duper rich, or if there's anything unusual about that area now.
Oh, you mean the lower part of the river where it was all deposited?
Well, I mean just above the old falls.
Okay.
In that area that you said was, very flat, indicating that it was once, a wetland.
No, I mean, that's all private land. I imagine it would be this fine alluvial soils that I imagine a geologist would be a pretty easy question for a geologist to answer. Now, in the lower part of the river, where we have 15 feet of sediment, samples were taken, and geologists have noted how the uniformity of those soils. Typically, when you sample an area like that, you'll find a distinct layering because floodplain soils get deposited over a series of flood events. The floodplain will flood, some sediment will settle out, and that'll happen over time and build up a layer of soil. And in contrast, the work that's been done in the lower part of the river clearly showed that all that material was deposited there in one big dump.
And would that mean, like one big deposition event, would that, do you have a sense of whether that would be over the span of a couple of days or a couple of hours or a couple of weeks or something like that?
Good question. I don't know. It's hard to imagine how, once the river started to break through that ridge. And, oh, by the way, regardless of whether or not that ridge was dug, whether it was helped by someone, this would have happened anyway. I think the river was kind of set up as an artifact of post-glacial drainage patterns. The glaciers were once covering Vermont, and the rivers drained away from the glaciers into the lake in a certain way. And the river's channels were continually adjusting. So the Poultney just happened to have this really weird artifact where it had this erodible ridge, and the river instead went around that, went over and went over this waterfall a little bit farther upstream. So it was really set up for this to happen after the glaciers retreated. Now, there's a little bit of an aside, but it's hard to say how long it took for the river to fully erode all that material down. I suspect it was maybe a day or two, but I'm just guessing that most of that stuff moved down.
Thanks, Paul. Usually is asking or commenting, do you suppose that the shallows in the lower Poultney today now protect the mussel and fish populations? If it had been navigable, perhaps those populations would have been lost.
Yeah, that's an interesting question that I thought about as well. The mussels and the fish that are there to a certain extent, particularly the mussels, river habitats are usually much more productive for mussels than river habitats are, or than lake habitats rather. So I suspect that, a lot of the mussels which are in the river were to some degree in Lake Champlain itself, but the fact that there's more of a river there than a bay mean that there's probably more diverse, more abundant fauna than would have been otherwise had it stayed a navigable bay. And I'm sure that the same is for some of these fish. Eastern sand otters are found in rivers, are not found in lakes. So they really rely on kind of river habitats to persist.
And another question from Len Schmidt. In 1783, was the upper Poultney affected enough by colonial activity to cause flooding sedimentation, or was the impact of settlement confined to below Fairhaven?
I don't know that for sure. Not being a historian, I do know or have an impression that the intensive period of land clearing in the upper part of the watershed was during the sheep era, which I think was a little bit later. Actually, I just did recently read a book on the history of the Otter Creek area, and the pace and patterns of development that were described in that book suggested that some of these higher elevation upland areas really weren't extensively settled or timbered at that period of time.
Another question, are LiDAR images of other Vermont river valleys available for the public to view? And as far as I understand, yeah, LiDAR is available for, well, statewide at this point. And I was about to post a link, but Len beat me to it. So in the comment bar, there's a link to the ANR Atlas where you can pull up some LiDAR imagery. Paul, is that where you'd recommend going for folks that want to look into LiDAR?
Yes, absolutely. If you can if you can access those on the ANR Atlas, that would be the place to go. I mean, otherwise you need some GIS software to pull that data up. But it's fascinating. That data was developed and funded. It's expensive data to collect, but it really has enabled a lot of groundbreaking work, science conservation-oriented work, with respect to a lot of different conservation initiatives relating to water quality in Lake Champlain and a lot of other things as well. But it's well worth looking at. You can look at you can look at a bunch of different rivers, and it's really fascinating.
Any other questions? Going once, going twice. Well, Paul, I want to say thank you on behalf of all of us and all of us here at the Nature Center for sharing this remarkable story with us. And I want to thank everybody who is out there for supporting the Nature Center and supporting our Resiliency Fund and checking out NBNC online. And I hope you all join us for more of our upcoming webinars. You can check out our website for what's coming up next. On Friday, we're learning about bee diversity in Vermont from Spencer Hardy from the Vermont Center for Eco Studies. But with that, Paul, I'll give you the last word.
All right. Well, thanks, Sean. It's a pleasure. And this is a story that after I unearthed it, I knew it was something that would be really interesting to share and really gives a neat perspective on some of the changes that have happened to Vermont historically, and also it gives kind of another lens to it, which we can look at, biodiversity and conservation kind of issues and values in places like the Poultney River.
All right, thanks everybody. Have a great night, and we'll have this recording up and available at our website in the next couple of days. So take care, everybody.